So what's really going on when we talk about mind-muscle connection or using internal focus cues versus external loading? When we're using external loading, like just having the dumbbell here and I'm doing my bicep curl, I'm going to use the least amount of triceps possible to do that exercise because the triceps are pulling in the opposite direction of the biceps. So what tricep recruitment is there is just to stabilize the joint. Now, when we use intention-based training where I'm trying to squeeze the bicep during that exercise, I can't make the dumbbell heavier. So if the bicep is going to be recruiting more or contracting harder, it has to have something to resist it, or I would just be moving the dumbbell faster. So when we do these squeeze things, what actually is going to happen is you're going to see an increase in the tricep activity, because what's happening is that co-contraction. The tricep is adding extra resistance to match what I'm trying to mentally do in terms of that intent on the bicep curl. The problem with that is, instead of just loading the bicep more, which would be the goal, like mind-muscle connection to the bicep, my goal is trying to get more out of the bicep. The problem with the tricep being the mechanism for that is it's creating inefficiency in terms of my recruitment pattern in terms of elbow flexion. It's actually decreasing my performance, making me more neurologically inefficient, and it's creating more stress around the joint by having this push and pull kind of on both sides of the joint, the two antagonists fighting each other. So when I'm doing a regular bicep curl and focusing on the load, it's nice, it's smooth, the movement is not, it seems essentially effortless. When I start applying intent, the movement is almost like, we'll say, jerky and slower, because my body's trying to manage what the hell am I supposed to do with this combination bicep tricep movement. If I really wanted to get more out of my biceps, it would be better to simply actually just put more load directly on the bicep, and you will see that the tricep will probably go up a little bit, because a little bit more load on this side of the joint means a little bit more of a stability challenge, but it won't be near as much as when I'm trying to do a co-contraction through internal cueing or trying to focus too much on that squeezy mind-muscle connection sensation-based recruitment. One of the research papers that's out there looked at using a bicep curl, and they did a barbell curl, and they focused on focusing on like internal cueing of squeezing the bicep versus the other cue was like get the weight up. That was literally the cue of like, that was the instruction. The problem with doing that with certain exercises, and you will see this creates confliction across the research, is why like when you look at internal versus external cue, you get a variety of different outcomes. In fact, and that's the same study that I'm referring, they also did the leg extension, and they didn't see the mind-muscle connection to show any improvement. In fact, it was less good on the leg extension. But on the bicep curl, it seemed like it resulted in more hypertrophy. The thing you have to consider with some of these exercises is how the internal cue may affect the physics of the exercise, which is essentially kind of affecting the volume. So if I were to take this exercise, and I would just be like, get it up, right? Up, okay? And that's as much of a cheat as like I can do without throwing it. I imagine, don't have any videos, I imagine if we're taking regular people that are not well trained, whatever, that getting it up might actually be a little bit more, lots of different stuff going on. If I'm doing this, okay, you're probably gonna see that there's not much in terms of recruitment happening. But if I simply slow this, so I'm not gonna do any internal cueing, right? If I just simply do this slower, what you're gonna see is the recruitment, especially if we look at mean recruitment, is gonna be much higher just by simply using control. Now, we take into account if I added some co-contractions in here, essentially what that does, that squeeze intent, forces me to slow it down. So an exercise like a dumbbell curl that is subject to momentum, or a barbell curl in the case that they used it, subject to momentum, especially if we're including bodyweight stuff, comparing that to an intention-based exercise is not going to be a good comparison because the physics change too much. It's basically like comparing two different exercises with two different amounts of volume. Not a very good comparison for or for mechanical tension or for a hypertrophy outcome. And that's why we chose to use an exercise that would essentially make the momentum a non-factor and make us able to keep consistent resistance across the different contraction types. So another thing that can lead to heightened sensation is getting us into positions where the joint is kind of compromised and essentially the muscles start having a guarding function around the joint. So one such instance may be actually taking the biceps here through an inappropriate amount of shoulder flexion, okay? And you'll probably already see like a spasmy like type contraction going on. But if I'm in here like this and I'm like using all this shoulder flexion in this plane and trying to do this, what you're gonna see is a very, we'll say, static looking contraction, right? Instead of having these nice waves that go up and down, it's gonna be like it's just going the whole time. That would be a hypertonic contraction where we're kind of guarding the joint more than anything else. But if I were to take the shoulder and go into the appropriate plane, okay, what we would see is significantly less staticky and more of kind of an up and down wave, right? Actually coming so much stronger just being in the correct spot, right? That we'll see more of that kind of up and down contraction rather than the muscles simply holding on. That hypertonic thing, that's what makes you think the muscle's working harder, but essentially what's happening is because you're doing like this low grade constant contraction, you're almost like slightly occluding and just building up metabolite, is all you're doing is just getting tired fast. So you may experience a burn, you may even get a pump in that tissue, but you're actually decreasing your ability to create stimulus in that tissue.
In this experiment, we started with an intent-focused curl. So as we're looking at this through here, essentially what I'm trying to do is focus on squeezing the bicep as much as possible, but that is going to result in increasing the amount of tricep stimulus. So at the top here, we have the long head of the bicep, and the pinkish color here, we have the short head. And then the bottom green represents the amount of force production, which is in newtons here. I wish I could curl that many pounds, but it ends up being around 30-ish pounds. We followed that up with a set with the same loading, but no intent, mainly just focusing on proper technique. And again, we have the same long head of bicep on the top, and then the force at the bottom, and the short head of the bicep in the middle. So this is the exact same loading without the intent focus. And the big difference to note here that's very obvious is the number of repetitions, is there's a lot more repetitions. Now, in terms of the actual recruitment data, we'll look at that in a second, but I'll give you kind of a spoiler in that if you look at kind of how big some of these waves are getting towards the end, is that we're actually going to end up with more mean amplitude doing this non-intent focus than with the intention based focus. Just to be sure, we did a second set of the intention focus to failure. All the sets were to failure, but just wanted to make sure that there was no question based off of the results that all of the sets were being taken to the relative same degree of failure. So you can see the change in rep speed and the change of weights and facial expression, etc. as we're going through that these were all basically the last full repetition, so the next repetition would not have been a full repetition at that technique. So it was technique-based failure. Full range of motion was the qualifier, so no partials, etc. Were allowed. And so this being later was one repetition shorter than the first, but because of the fatigue, we're getting a little bit higher amplitude here, having to recruit a little bit more. So one would think that this would be even more show even more recruitment, but as we'll look at the data here in a second, that wasn't quite the case. Here we have a table of the EMG data and results comparing the three different sets we did, as well as us rep equating the no intention set as well. So in the top row here, we have the first set where we're focusing on maximum intention, focusing on squeezing the bicep. The second row here is the set that we did with no intention other than the biomechanics of just, doing elbow flexion, but not focusing on, trying to squeeze the bicep any harder than the load required. And then the third row here is where I actually equalized. So I basically extracted the data just from the final reps of the no intention set so that I could pair the same amount of reps to the intention based set. And I actually also ran the intention set a second time. I also ran the intention set in a second time, which was in a fatigue state because I had done the intention and the non-intention. So I basically done 2 sets to failure. We did a third set in there. The theory for that, just so you know the relevance, is that coming into a more fatigued state, we would expect to see greater amplitudes because in a fatigue state, you'd have to be reaching out to more motor units to try and do the work. So we would expect to see those numbers go up. So just to kind of eliminate that being a factor of the data of the order that we did these in, or any amount of fatigue, even though it was, we were taking about 10 plus minutes rest between these sets of biceps, which is pretty adequate rest for a set of biceps. I just wanted to throw that in there to show that the data would still move in the appropriate direction regardless of the order and in a state of fatigue. So basically, everything would be set up in the scenario that final intention set should have been the highest reading thing across the board. So let's review the data here. Just really quickly, we'll look over at repetitions on the far right here. 9 repetitions in the initial intention set. Lost 1 rep on the final set, but I got 13 total reps on the no intention set. So about a 50% increase when we removed the intention per se. So a little less than. Now, we look at the mean comparisons here. The mean went from 393 to 537 on the long head, which would have been the primary muscle, for this exercise. The short head, it moved, but I wouldn't consider that a huge significant difference going from 420 to a 464. From a combined mean, which is just the sum of those, we're looking at a movement, of about, 190, points in terms of how the amplitude is being measured here. Now, when we equated it for the end reps, and especially if we compare that here to the larger set, we see that when we look at just the final repetitions, when we start rep equating this, the averages for the no intention set go up. And that's because over the course of a set, you are going to start increasing amplitude. As you're starting to fatigue, you're going to be reaching out to more motor units, to higher threshold motor units. So we're going to see that amplitude go up, which is why, it's important to take into consideration that we're averaging across 13 reps, meaning that the earlier reps would have been much lower in magnitude compared to the later reps over 13 than they would a set of a lower rep range. So if we actually looked at, the last 8 here versus the last 9, since we are functioning on an average base, this gives us a better comparison, this 393 to this 616, or for the sake of trying to support the intention set, this 616 to this 508. This gives us a better comparison in terms of like the actual, we'll say like maybe effective rep difference between the two. Because when we're focusing on intent, essentially what we're doing is we're consciously adding resistance from the antagonist before we're tired. And as you get fatigued, what's going to naturally happen is your body's basically going to be fighting your ability to create that co-contraction to try and overcome the resistance. So when we look at the intention sets, if you go back and look at those waves, you'll see that there's less of a change over time than there is when we're focusing on no intention. And that's because essentially you're kind of like preloading some fatigue with fighting yourself with the intention set. But the net of that actually ends up being far inferior with this proxy, which is focusing on the amplitude here. So we actually see a bigger difference when we focus on equaling out the reps, and that even accounts for if we did that second set under fatigue. So the data in terms of looking at the mean amplitudes, whether we do the whole set or we rep equate it, seems to be pretty clear by this proxy that a no intention protocol would be superior for stimulating mechanical tension if we're looking at using EMG in this way as a proxy, which I think is fairly useful. But you could make some arguments against it, which is why we have multiple layers of data. A couple things that I want to talk about just for the quality of the data, because I had mentioned that doing exercises where adding the intent changes the physics of the exercise kind of distorts the data, because it's almost like we're comparing two different exercises. So we used a cable, and we actually had a force sensor right on that cable. And what we're able to do then is actually get the measurement of the average tension between the handle and the cable throughout these sets. And was able to keep that within half a pound difference across all of these sets, right? So the average amount of tension at the cable here was between 31.92 pounds and 31.47. So less than half a pound difference average tension or resistance across all of those sets. And then the peaks were also very close. So this would have just been the highest point in there. And I think we're up to maybe 2 pounds difference. But similar to like mean and peak, average and peak here, is that the peak really is kind of an insignificant data point. I mean, it's nice to have in there because it gives it to us. And I mean, in this thing, it is telling pretty much the exact same story as the mean, but just to a less consistent degree. But there you can see that from a control perspective, we use the same loading, and we also achieve the same average tension load on the limb, right? Because I could use the same dumbbell, and if I'm moving a dumbbell at different speeds or being more explosive, the actual average loading or tension across the sets would be very differently. And that's why they probably got the results they did when they did that dumbbell study where they compared a barbell study where they compared an explosive get it up intent versus a focus on intent. Is the speed of them likely drastically changed the volume and almost turned those into two different exercises with different resistance profiles, different volume, different average tension, etc. So just to give you guys a visualization, we have a chart here. The blue represents the long head, which would have been the more primary of the two biceps being worked in this particular position. The green is the short head. On the far left here, same order, we have the first intention set. The average of the no intention set as a whole is the second two bars. And then my third set of bars here is the rep matched no intention set. So this is not using intention, just focusing on good technique, but equating the same number of reps. And then this on the far right is the less, or we'll say the bonus intention set that we did in a state of fatigue afterwards, just to confirm that it would not supersede the prior data, which it didn't. It was still lower than the average for the no intention set, the first one, and it was significantly lower when we rep equated it. So I'm not going to bother showing you guys the peak comparisons. We're just going to jump right to the next portion of data that we collected, which is the data that we collect with the Moxy. And so what the Moxy does is EMG is electrical activity, and what Moxy is doing is it's using basically infrared light sensors to measure the amount of blood and how much of that blood is oxygenated, specifically the hemoglobin within that muscle tissue. So this chart here represents the oxygen levels, the oxygenated hemoglobin. So the blue is the max intention set, and the green is the no intention, just focus on technique set. Obviously, you can see that the green one is longer because we were able to achieve a longer time under tension and more repetitions. But if those repetitions were lower quality, less productive, what we would expect to see is that the green line would not have dropped as fast, so it wouldn't have declined as fast, and it wouldn't have went as low, or it would have taken a lot longer to bottom out. Because essentially, if you are creating more tension within a muscle, you're going to be consuming more fuel, but also that increase in tension creates kind of an internal occlusion effect, which makes it harder to get blood in and out of the muscle as well. So what we're kind of using this for on top of the EMG is an idea of, effort, intensity, and are you actually, because in EMG, like the number doesn't mean anything like itself. Like if I measure somebody, I don't know if that's a high or a low number for that given muscle. I can only compare it to other exercises and see if it goes up or down. But with the Moxie, what I can look at is like, are we actually like depleting sufficient oxygen in there to give me an idea that you are actually taking that muscle to an effective stimulus degree of effort and like closer to failure, et cetera. So what we saw here is the actual no intention set actually declined faster. So it showed that like there was more consumption of oxygen and likely more muscular tension going on, because not only did it decline faster, but it averaged a low overall reading throughout the set and longer. So it looked like it consumed the fuel faster or constricted faster, which would both be signs of more tension. It averaged a lower amount and it went for longer. So if we're looking at proxy of stimulus between the combination of increased amplitudes in the EMG and increased oxygen consumption and more total volume accumulation, it seems to be that not focusing on the intention would be a far superior way of trying to stimulate that muscle tissue, especially in regards to mechanical tension. So this last one here is just kind of looking at things at a percentage level and summing up the difference between these two. So all of these numbers were reflective of improvement in using no intention and just, keeping good technique. So if we look at comparing the full sets, there was a 27% increase in amplitude for the So if we look at the full set, there's a increase of 27%, but if we look at just the reps equated, the final 8 of each, it actually moves to a 36% difference in the mean long head and a 23% in the mean short head. You have your peak numbers over here. Again, not really relevant numbers. I mean, you see only a 1% difference here. But then we look at volume. We were able to get an extra 4 reps, which in this case is an increase in 44%, and about 10 seconds of what we call, TUST, or time under significant tension, because we're looking at the actual window of like the bottom of this U-shaped curve, right? So I don't really care about reps that would be, non-significant. I don't really care about the reps that would occur over here. I'm looking at the reps that look like we're at a point where we're getting effective reps based off of that Moxie data. So not only did we get more total reps, but we got more time under tension, where we would expect there to be a greater amount of stimulus per repetition occurring. So overall, it seems pretty clear that using these tools, that not focusing on the intent, but focusing on having a good exercise and good technique is going to be the superior way to get the stimulus that you're looking for.